Hi, this is Michael from the Cade Museum for Creativity and Invention in Gainesville, Florida. Here at the Cade, we'd like to see science through the lens of invention. Today we're going to learn about the components of CRISPR technology and how it works. Monumental scientific breakthroughs often come out of seemingly mundane circumstances through a series of discoveries and illuminations, and here at the Cade we call those aha moments. One seemingly mundane circumstance with yogurt cultures led to the development of CRISPR. CRISPR is a genetic engineering tool that uses sequences of DNA and its associated proteins to edit the base pairs of a gene. As a tool, it's often described as a pair of molecular scissors, which is used to precisely edit or remove genetic information. Like regular scissors have two blades, the molecular scissors of CRISPR consist of two components: the Cas9 protein, which can cut the DNA, and a guide RNA that can recognize the sequence of DNA that will be edited. The guide RNA is made specifically to match a portion of DNA that is to be altered. Once created, the guide RNA is attached to the Cas9 protein, and this complex is introduced into the target cells to guide the RNA to find the target DNA sequence. The DNA sequence is then matched with the RNA and then cut, where it can be either repaired or altered. Many of these treatments are still being researched, and I encourage you to learn and discover more on your own, as CRISPR will become increasingly used in genetic engineering over the course of our lifetimes. Now, what does CRISPR technology have to do with yogurt? For more than 30 years, scientists have been sequencing bacterial genomes, and in 2005, researchers working for a dairy food production company were trying to find a way to protect their yogurt bacteria from viral attacks. They noticed that there were sequences in yogurt that matched the sequences of those infecting viruses. They knew those sequences had to be involved somehow in antiviral defense, but they still didn't understand how it worked. Several years later, two researchers from different fields began talking about these sequences of natural bacteria communities, and they began discussing the possibilities for these sequences. This led to conversation, to more research in the field, and the naming of this CRISPR technology. This collaboration led up to the 2020 Nobel Prize in Chemistry, being awarded for Emmanuel Charpentier and Jennifer Doudna. These ladies discovered the genetic scissors which can be used to rewrite the code of life.